Let's look at an example of positive velocity and positive acceleration. Up ahead starts at the 0 meters and speeds up. So the 0 meters is right here. That's the reference point. That's going to be the bottom of the position time graph. And you can see that every second that goes by, he's spacing himself out more and more from the previous second. Right, so that's a sign that he's speeding up in this case. We can find the velocity by finding how much the position changes every second. And you can see those velocity numbers get larger. They're always positive as he keeps on moving away from the reference point. You can also find the acceleration by how much the velocity changes every second. Just look at that. From 3 to 9 is 6, from 9 to 15 is 6, from 15 to 21 is 6, and from 21 to 27 is 6 as well. The acceleration was constant. It was positive. Because velocity and acceleration both have the same sign, right? They're both positive. He is going to speed up. Remember, if one is negative, one is positive, then they slow down. If they're both positive or both negative, then it's going to be a speed up. What does the position time graph look like for this data? All right, so if we're going to graph our position numbers as a function of time, the position versus time graph looks like this. And so you can see that it's curling upwards, which symbolizes a positive acceleration. And you can see that it's getting steeper, which shows an increase in the speed, meaning it's getting faster as it gets steeper. So flatter slope is slower speed, steeper slope is faster speed. What about the velocity versus time graph? There it is. So we graph these velocity numbers like right in between the times in which we found them, and then run a straight line through them, and you see that we get a constant slope. That slope, that line, is actually acceleration, right? So the dots are just the velocity numbers, but the slope itself is the acceleration. As we'll see, acceleration is the slope is rise over run, and that line rises 30 as it goes over 5. 30 divided by 5 is 6. All right. So acceleration is equal to the slope of this velocity time graph, which is a positive 6. The positive acceleration and positive velocity means that he is going to speed up as he moves away from the reference point.